Okay, so the second speaker for the session is Josep Berral, and the talk is about Aloja-Ml, a framework for automating characterization and knowledge discovery in Hadoop deployments. And while Joseph's setting up, is just checking on the third speaker, the mining. Oh, there you are. Cool. Just checking you were there. Okay, thank you.
Okay, so Josep Berral. I come from the Barcelona Supercomputing Center, working in a joint initiative with Microsoft about ALOJA-Ml and Hadoop deployment. So, about Hadoop, suppose you're familiar, but if not, just a framework for running jobs. You have a job, and you have a job. You want to, you can parallelize it, and you send it to worker machines that process parts of this job, and finally they reduce all the sub-results into the final results. One thing that happens with Hadoop is that the runtime execution is quite complex, also distributed, and it's hard for knowing exactly what's happening on the system in very detail for all the jobs and all the deployments possible. One of the initial motivations that we had is that, well, if we set up a deployment of Hadoop and we want to optimize Hadoop for that deployment or the set of jobs that we are going to run, we had to run several executions or several tweakings of Hadoop, finding the best and optimal configuration for that exactly deployment or that exactly job. And one of the things we thought is, well, instead of running a lot of executions, let's try to run fewer executions and create a model. From this model, we will be able to kind of simulate or kind of have an oracle, have something that predicts this Hadoop behavior, giving different configurations before trying it on real, and spend time executing jobs and spend money on the resources that these jobs consume. And then, well, observe, once having the model, we can observe the behavior if we open the model, or also we can do lots of other things with the model, that as we will see. This job is framed in the ALOJA Framework. That's it's based on the idea of which Hadoop and data center configuration is the best in cost-effectiveness terms. This is if I have kind of deployments with different hardware or different providers with different options, and I have different configurations, which one will bring me to the best solution, in meaning that job running less time with less resources, and then we can compare. So the idea of the framework was to run in several situations, several providers and solutions, and compare them, try to find interesting things, and said just this is better or this is worse, but this runs better in this situation, this runs better in that other one. So this framework, just quickly, now it's a piece of software that you can get, and a user can schedule Hadoop executions. The framework is in charge of retrieving the information from these executions and showing to the user some visualizations in a friendly way, so the user does not have to be an expert to understand what's happening with executions and different setups and different configurations. This, as I said, this project is an initiative of the Barcelona Supercomputing Center, Microsoft Research, towards comparing big data deployments, to compare providers and provider options and configurations, but seeking to provide knowledge and tools to the community. So everything that we have here, the tools, the methods, the things that we find, even the data set is public and available. You can go to the website of the project and download whatever you want and deploy at home, test it at home. If you want to contribute, you can contribute with findings and new data and new executions, or just get the data to test your methods or whatever you want to do if you need data. Oh, we have data. So, once we have this ALOJA framework to run Hadoop executions and visualizing, Then here what we do is to add the predictive analytics. So we add some pieces of data mining machine learning in order to obtain something else than not just visualization of what's happening on my Hadoop system with this option or this other option. And we deploy model-based methods. As we have a model, we can use the model for other things like, for example, recommendations or anomaly detection, or trying to find best configurations for a specific situation. And that's what we do in Aloja-Ml. Actually, ML is for machine learning. So, in Aloja-Ml, it's the Aloja Predictive Analytics component for modeling benchmarks. Here, at this time, we are using as jobs, as reference jobs, benchmarks from the Intel HighBench suite of benchmarking for Hadoop. But in the future, we plan to be able to process any kind of job by just preprocessing it or looking at making some trials of it or some executions. But we're working on that. At this time, we're just focusing on benchmarking systems that at the end, we want to compare providers and solutions. So we have the benchmark executions. We pass through our predictive analytic tools that I will show now. And then we get the benchmark behavior if we observe the models. We can obtain knowledge if we do some post-data mining on our models and results. And we can obtain oracles for making predictions and using these predictions for what we need. So, well, as I said, imagine this is the ALOJA framework. The user comes here, get the data set of ALOJA. That's a set of executions that we already have. And it's expanding day by day. Each execution we do, we put into the data set. And the user slices this data, selecting, I want to observe this provider or this kind of configuration of this hardware component. And I want to visualize it at the end. But in the middle, we add here all the model stuff. So we learn models, and we apply for outlier detection, for example, or anomaly detection, if we want to call in more general way, to filter execution, say which execution went wrong, which execution took anomalous time to run, or used more resources that it needed, or that we expected it to need. We can also do prediction for saying, okay, this execution in that kind of environment, how much will it last, or how much resources will it consume? Also, we can do clustering we will say for some recommendation, saying, okay, what should they run in this system to make a good benchmark of a new deployment that we never had before. And we can do other things. And at the end, what we do is to show the user, because the final, the objective, the goal of the system is to show the user things so the user can observe and think a little bit about what's happening. So, we have the ALOJA dataset. This is the dataset that we already have, and as much executions we do, we put inside the dataset, and it's growing. At this time, it has more than 40,000 Hadoop benchmark executions from the different kind of benchmarks or micro benchmarks from the HighBench. We have input features like the benchmark information, like the configuration information. This is the configuration of Hadoop and of what we could call the software information, and the deployment information about the infrastructure that we have, the kind of options that the provider is providing us. And the output features, we have service level objects that at this time we are using execution time as our main reference and goal, but we could also use things like CPU consumption, memory consumption, network bandwidth, or disk usage, and other resource things that with some time it will come into the project. And in this data set, we have we have tried execution with different Hadoop versions, with different underlying infrastructures from local deployments to deployments in Azure, in HDI from Microsoft, and other kind of deployments that we'll publish at its time. And we are expecting for other providers of cloud and Hadoop services to let us to run executions in their systems. The benchmark with different input sizes, not only limited to the standard, And also with some anomalous executions. So we kept the anomalous executions to test the anomaly detection mechanisms and other mechanisms to see if our models are resilient to noise and to bad information for learning and creating the models. We kept them, so they're still there. And for modeling, we use the three-step learning methodology that at least we get the data set, we split in at least 3 parts, one for training, one for validating. Then with training, we create the model. With the validation, we test this preliminary model and we iterate in order to seeking, this is done automatically, to seek for the parameters of each machine learning algorithm in order to find what we could consider the best model as we could. And finally, we test with the testing set in order to testing set never seen before in the training process. We tried different split sizes and split distributions from here, just to provide enough data for training and enough data for testing, not putting all the data in one side or another one. The platform has available different learning algorithms like regression trees, nearest neighbor methods, linear or multinomial regressions, and some neural networks with some degree, because neural networks require very exhaustive tuning, depending on how you see. And doing this automatically is quite hard, but we're working on that, also knowing that each algorithm has its pros and cons. And for what we saw for learning results, we had kind of good results, thinking about that this process here was done automatically, and it was really close of what a data miner could do with the R console and then the R or Weka algorithms doing all the process by human expertise. And also, the error always depended on the benchmark. Some benchmarks are harder to predict than other ones because some of them are more irregular than the other ones. Also, some have random inputs, and some benchmarks are affected by this random input thing. Also, we have the anomalies. So, the implementation and technology of the ALOJA framework and the Aloja-Ml is basically for the environment ALOJA, it's Hadoop plus LAMP plus background. This is Hadoop deployment. We are dealing with Hadoop, so we have Hadoop. All the software from ALOJA is deployed in Apache, MySQL, PHP, so the user communicates through web interface. And also, this software communicates to Hadoop to run the executions and retrieve the information. And also Vagrant, because if, as I said, this is intended for the people to get and try at home or get and do whatever they want. So it's all packed in a virtual machine, so you can get and deploy at home with less problem as possible. And for the determining tools, we use R and a little bit of Java because we borrow some methods from the Weka package. So we use a little bit of Java. Good thing is that we can deploy this locally, or we can deploy it in Microsoft Azure and Azure-ML. Thanks to that now Microsoft introduced it there in the Azure-ML, we can deploy our methods in the cloud, and well, we have the resources in the cloud for the expensive in time and processing machine learning processes that we have in some occasions. So, I told you that we had this framework, we could do modeling and prediction, but with the models also we can do other things, like for example the anomaly detection. Here we use a model-based detection procedure that we run executions, then once we have the model, we expect the execution time of those executions, and we look if they match. And at this time, we will believe that the model is the truth, and because we created an excellent model, and we believe that it's the truth. And if they don't match, or they don't match enough, we will consider that the execution is an anomaly. Here we consider an anomaly as something that does not behave as we expected. Also, the thing is that these executions are flagged for the operator or the administrator or the architect to review later. But also we compare the executions with already seen executions in order to see if the neighbor executions behave as expected. Then we will consider that maybe this anomaly is actually an outlier, something that's wrong. But if not, we will consider that maybe it was the model that was not able to predict this execution correctly because it had not enough examples, or it was not able to model this region of the space of the configurations and executions. Also, we will flag it. And the thing is that when the operator or the user that uses Aloja comes here, hit the button and say, okay, test my executions, he or she gets a list of these executions are okay, we can put the tick on them, or these executions are not okay, let's see what happens. Also, the Aloja platform has the visualization tools for examining these executions in detail. Well, here is the testing the Aloja dataset. We found outliers and warnings. These are the anomalies and the normal ones. That was the majority of them. Also, the second case of use, it's kind of a guided benchmarking. It's a recommendation. Let's say that we have a deployment and we run benchmarks on that deployment. And then we create a second deployment, or we modify the first deployment, and we want to run the benchmarking again in order to compare, to say, okay, we improved or we didn't improve, or what's the improvement that they got from one to another. For the first one, we run sets of executions to benchmark. But for the second one, instead of running again the same set of executions, we want to run less executions. And how we do that? Well, we get the first set of executions, and we try to obtain those executions that a small set of executions that represent with the highest loyalty and fidelity the first set of executions. We do this by clustering. We get the set of executions. We do, in this case, k-means algorithm. K-means because we can play with the k. We can say that, okay, for the second set of benchmarking, I want to use to run at most k executions, so I set the k. And I run the clustering algorithm, hoping or expecting that the results of clustering, that are the centroids of the clustering, will represent with some kind of fidelity and loyalty what we run in the first deployment. The objective, the goal is to run as fewer executions as possible because they cost money. And that's what happens, that the more is the k, the more executions we introduce in the second deployment, the more the fewer is the error, or the compared to the first executions, but the cost grows. So here it's just to decide at which point of the trade-off we want to be. We want to run lots of executions with a given cost, but and creating an exact benchmarking like the first one, or reduce it a little bit for saving costs, but having some kind of error between one and another. Well, we decide at which point of here, of this crossing, we want to stay. And there are other cases as well. We can use the models also for just as oracles, that I have a configuration and I want to know how much it will take to execute, to decide for planning, scheduling, or whatever. We need the prediction, or we can get a set of configurations, predict that we didn't run before, predict all of them in order to see which one will be the faster, and decide that this one is the one that's going to be queued in our Hadoop system and configured in the Hadoop system, or maybe just use the model for looking for the feature relevance, or discover which features the model seems to consider the most important or not, and display it in a user-readable way. That's also interesting, because if you have to choose configurations or deployments, these features being different configurations or different elements of the deployment, like hardware, like an option of a given provider, you have to go choosing one by one. and you like to know the order of importance. And well, concluding, this is the Predictive Analytics Enhancing Benchmark Cost-Effectiveness Visualization. This is the Predictive Analytics part of ALOJA in order to do some data mining in Hadoop executions. With the modeling behaviors of this Hadoop, we can realize predictions and using tools for execution prediction, anomaly detection, recommendations. And next steps are basically, we want to keep improving the platform, keep improving the tools, adding new tools. Also, we encourage people to download the tool, use it, or download the dataset, using the dataset, testing new methods. Also, if people runs execution with ALOJA or has executions, logs of executions of Hadoop, if they want to share with us, we're gladly to accept this and see what we can do with these executions. Also, our executions are always public, so you can download them. And well, we want to expand features and expand the data set. There's a demo line in this address here. It is URL here. You can go try it. Also download the data sets. Also try the demo online. So, thanks for your attention.
Thank you. Okay, I think we've just got a minute for questions. Any questions? All right. I've got one. I think you touched on it. With using the Oracle, and I'm keen to use it. I've got lots of questions about keen to use the Oracle to get an estimate. Does it tell you, and you sort of touched on it about different degrees of accuracy depending on how dense the configurations and things are. Does that currently work now? If I put in a request and get some advice, will it tell me the error bars, or does it just say maybe it'll take this long?
Well, the Oracle, the idea of the Oracle is just providing the setup that you have for the job.
Yep.
Tell how long will it take in an expected situation without at this time interferences or in a regular interfered system. Okay. Also, we can ask for resources, etc. But well, right. So if I would like to show more results, but I'm in the poster section, so.
Oh, good. Okay, look out for it in the posters.
Okay,
we'll
thanks.
drop by. Thank you.